So in this class, let us discuss a problem on linear motion. So considering the case of uniform acceleration and retardation, because acceleration can vary also. So but in this problem I will take with uniform acceleration. Now that means the question here is like this: a train starting from rest is uniformly accelerated during the first 250 minutes of its run and runs next 750 meters at uniform speed. It is then brought to rest in 50 seconds under uniform retardation. If the time of entire journey is 5 minutes, that is 300 seconds, find the acceleration with which the time started. So you have to understand here that in any problem of linear motion, so if you take, there will be 3 stages. Let us say A is the starting point, so it starts from rest. Initially it starts from rest, that means your initial velocity is 0. Up to certain distance, let us take this as B, up to certain distance, the velocity increases. So velocity is 0 here, it increases to some value here, let us say B. So it is uniform acceleration means the thing is it's a straight line. So therefore, up to certain distance, let us take this distance as S1. So starting from rest up to distance S1, velocity increases to value V. Then the velocity may remain constant for some other distance. So let us take this is BC, S2 is the distance. So S2 is the distance through which the velocity remains constant, that means it is V only. Then brakes are applied and the body is coming to rest once again at D. So the body comes to rest at D so that the velocity decreases. That means it is the case of a retardation and this distance we can take S3. It means the total distance traveled will be S, that is S1 plus S2 plus S3. Similarly, the time to travel from A to C, I will take T1, time to travel from B to C as T2, to travel from C to D as T3, then total time of travel will be T small t, that is T1 plus T2 plus T2. That means there are 3 stages here. We can see that here in the first stage it is the case of uniform acceleration. That means acceleration increases here, that means velocity increases, therefore acceleration is positive in the first stage. In the second stage, acceleration is 0 because velocity remains constant. Velocity V remains constant, so V is constant, therefore acceleration is 0. Then later on, the case of retardation will come into picture. Uniform retardation will be there. That means uniform retardation means negative acceleration. So A is negative. Then it comes to rest. So these are the 3 stages of linear motion. So initially increasing velocity will be there, uniform positive acceleration will be there. Then to certain distance, over certain time, velocity remains same. That means there is no change in velocity, means acceleration is 0. Then the acceleration velocity reduces to 0. That means the body comes to rest. Then in that case acceleration is negative. That means it is uniform retardation. If you observe this problem here, so let us start like this: a body starting from rest. So A is the point of so it starts from rest at the point A. That means when t is equal to 0 initially. Okay. Then it is uniformly accelerated during the first 250 meters. That means here S1 is given. S1 is equal to 250 meters. That is given. And initially you have this the initial velocity is 0 because it is starting from rest. I will take it as 1. Now let me take like this. First phase means this is the case of uniform acceleration. uniform acceleration, body is traveling from A to B. So you have to understand this problem clearly. There are so many parameters here. Distance is a parameter, time is a parameter, velocity is a parameter, acceleration is a parameter. So some of them may be given, some of them may be asked. So the procedure may be same. So S1 is 250 meters, U1 is 0, and when it comes to B, the velocity becomes V here. Then I will take it as V1 because it is V1 for the first phase. Now, what I say is your first 250 meters orbits run and runs next 750 meters at uniform speed. That means the second phase, when the velocity is not changed. So this is uniform speed. Uniform speed means acceleration is 0. A will be 0 in the second part. This is from B to C. The body moves from B to C now. So in this case, what are the data given? Let us see. Next 750 meters means this distance, S2. S2 is equal to 750 meters. Then it is then brought to rest in 50 seconds. That means the third. So up to this it is over now. Now the third phase. In the third phase, the train is coming to rest. That means it is uniform retardation. Uniform retardation. If it is that is from C to D. It is from C to D. Okay. So it comes to rest at D. So in this case, what the data has given brought to rest in 50 seconds. That means T3. He has given T3 value. 50 seconds. See, you can see here. In each phase, he has given different data. So it is 50 seconds. Now then, what he has given here is, of course, here acceleration is not known. A1 is not known. Even here A2, A3 is also not known. I will take this as 1, 2, 3 like this. So A3 is also not known. That also we have to find out. If the time of entire journey is 5 minutes, entire journey means it is kind of T. So T is T1 plus T2 plus T3 is 5 minutes, means it is 300 seconds. Please convert everything to meters and seconds. That is the estimate. 5 minutes means 16 to 5, 300 seconds. Find the acceleration with which the train started means A1 we have to find. So please note that here, in the first case, I am going to take A1 as the acceleration. Second part, of course, A2 will be 0 because there is no change in the velocity, acceleration is 0. Third part is A3, which is retardation. Now here A1 and A3 they are not known. These are the given things. So here, see what happens here is to find out A1. Now we have to use the equations of equilibrium, equations of linear motion for all the three stages. So we know the three fundamental equations. So that I will write here. The three basic equations of linear motion are, in the last class I have derived it. Equations of linear motion are, the first one is V is equal to U plus AD or U minus AD. U plus AD we are using if it is positive acceleration. U minus AD we are using if it is retardation. So either this or this we are going to use. Second equation is S is equal to ut plus half AD square if the acceleration is positive, or S is equal to ut minus half AD square if it is retardation. Then V square is equal to U square plus 2AS if it is acceleration. V square is equal to U square minus 2AS if it is retardation. So among these three equations, we can use for the first phase, because in the first phase acceleration, train is getting accelerated, and for the third phase we can use this retardation equations. This is for third phase. In the middle phase, since there is no acceleration, only equation we can use here is S2 is equal to velocity V2 into T2. That's all. Because there is no acceleration, A2 will be 0, though there is no term coming for that what is that acceleration term will not be there in the second phase. Now, one by one we will see. All of you observe carefully here. I will take the first phase now. I will take the first phase. What are all the known things in the first phase? Let us see. Unknown things we will decide. So now, what I will do here is, in the first phase of the motion, so the diagram is like this. Your initial velocity I will take u1. Final velocity you don't know. Acceleration you don't know. But distance you know. S1 is equal to 250 meters. Now we have to use we have to think which equation we have to use. So here two unknowns are there and two known things are there. So we have to use the equation such a way that among these three we have to use any two equations. For example, if I use v is equal to u plus at, so both a is not known and t1 is also not known. See here, t1 is also not known. We are not given t1, so t1 is also not known. That means three unknowns are there here. So we have to use all the three equations for that. In the second phase, what I do here is, I will take the initial velocity as u2. Please note that this u2 will be the final velocity of the first phase. So this whatever is there here, this is v1 as well as u2. So please note that here u1 is 0, v1 whatever is there, that itself is u2. Then whatever v is there here, that itself is u3 here. So this is, I can take it as this value as u3, and here please note that u2 and u3 they are same. Okay. So and this here, this one is given v3. So what I am doing here is u1 v1, u2 v2, this becomes v2, u3 v3. So like that I am taking and differentiating. So u2 is the same as v1, which is also not known. So in the second part, 750 meters, S2 is known. S2 is known, 750 meters, and you know this equation, S2 is equal to, so that whatever v1 or u2 is there, multiplied by t2. Here t2 is also not known. See, t2 is not given here, so that is also not known. t2 is unknown. Next, coming to third phase. In the third phase, here when the motion is under retardation, so he has given the time. Time he has given t3. t3 is 50 seconds. The travel time he has given, and whatever final velocity is there for phase 2, it becomes initial velocity for phase 3. So u3 will be v2. So here v2 is also not known. Of course, v1 is equal to v2 here. Please note, v1 is equal to v2 here. So therefore, whatever u2 you have got here, same thing is there for v2. So v2, u3 is equal to v2. That's what I can write. Then t2, sorry, this equation. Yes, he has not given acceleration here, but he has given that the body comes to rest. That means v3 will be 0. So u3 is v2, but v3 will be 0. Now, here one more thing he has given. The total time he has given. So total time is 5 minutes. That means t value he has given. T is t1 plus t2 plus t3. 5 minutes, that is 300 seconds. So this is what he has given. So now we have to find out here the then brought of course t3 is 50 seconds. Total time he has given 300 seconds. So wherever t in the first system t is not given. In the second one also t is not given, but in the third he has given t3 and total time he has given. So using this data, how to find out the unknowns, let us say. So this problem can be easily solved by writing the VT diagram. So very important, VT diagram. So here, what I have written here, that is your VT diagram. So now let us try to draw that velocity time graph for this and we will solve it. So please understand this problem clearly so that any problem of this kind we can solve by just understanding this VT diagram or VT graph. VT diagram. So here the thing is same thing I am going to write here. Initially the body will start from rest and as the velocity increases, then it remains constant, then it decreases. So there are three phases here as I already told. So A to B is acceleration, B to C is acceleration 0 or constant velocity, C to D is retardation. Now what I will do here is on x-axis I will take time t in seconds, whereas on y-axis I will take velocity. So if you plot velocity versus time in meter per second, of course, you get what is called as the VT graph. So the area under this area under this graph is nothing but displacement or distance traveled. Area under the graph is nothing but even S, distance traveled or displacement. So this concept we have to use here. So please note that area of VT graph gives the displacement of the distance traveled. Now in the first thing, so let me take this as EF. So this area of this triangle AEB gives the value of S1. Actually this is T1, from here to here T1, from here to here T2, from here to here T3. Among these three, this T3 is given, only T3 is given 50 seconds. This is given as 50 seconds. These two are not known, but total time he has given 300 seconds. So we have to note down what along the given phase. So total time is from A to B. So for the third phase he has given 50 seconds. T1, T2 are not known. S1 he has given. Please note that S1 is 250 meters. That means the area of this he has given. So now I will go one by one. So first phase I will take. First phase is from A to B. It is under uniform acceleration. Actually this problem we can do in two methods. One by using this diagram, I think that will be easier. Another by using these equations. You can try using these equations also, you will get the same answer. But I think this VT, by drawing the VT diagram, you can easily get the answer. First phase, what I do is I will take the area of triangle AEB. It is given by half into T1 into, now velocity, this velocity is B, so that value you don't know, so I will take that as B, half into T1 into B, half into T1 into B. So this is the area. Here both V and T1 they are not known, but this area is nothing but S1. I have told you, So because ordinate is velocity, exercise time, if you take the area, it is velocity into time. Velocity is meter per second, time is second. When you multiply meter per second into second, you get in meters. That is displacement. So this value 250 meters. So this value So this is one equation. So V into T1. I will take this value as V. This also is V. So V into T1 is equal to 250. So let me take this equation as 1. So next, second equation, for the second phase, I am going to apply the area formula for the second phase. This is from B to C. Constant velocity or acceleration is 0. In that case, you can directly use this. So area of rectangle EFCD or BCFD. You can write like this. So it is T2 into V. Area of rectangle T2 into V. This gives S2. S2 is the distance traveled. It is given by the area of the second part. So this is equal to S2. But anyway, he has given the value of S2 also. It is 750 meters. So we got another equation. T2 into V is equal to 750. So this is second equation. So first equation is this. Second equation is this. Like that we have then only we cancel. So here half 1 second. Here half into T1 into V is this much. So this becomes 500. This number 500. 2 into 2 500. So this is the second equation. Now we will go to the third phase. In the third phase of the problem, if you take the area of the triangle, so area of the triangle will be now, so this will be S3. Please note that area of this triangle will be S3. So I will write the equation for third phase now. Third phase from motion is from C to D. C to D. Here area of triangle FCD is given by half into T3. So here T3 is 50. Please note it is known. Into height is V. Velocity V. That means it is 25 times V. So this is equal to S3. S3. Now you don't know the value of S3 here. So S3 is not known. So now what I can write here is 25 into V is equal to S3. So here if we use the total distance, then we can find out that, but total distance is not given here. First 250 meters, next 750 meters, that's all he has given, but total time he has given. Okay, anyway, no problem. Let us see how we can solve. This is the third equation we will get. Now we have to see how we can solve this. One thing is, he has given that T1 plus T2 plus T3 is equal to T. So you have to use that concept now. Total time he has given. We have total time is equal to 300 seconds. That is 5 minutes. Which is nothing but T1 plus T2 plus T3. So T3 is 50. So your total time 300 is equal to T1 plus T2 plus 50. Or in other words, T1 plus T2 is equal to 300 minus 50. That is 250. So this is another equation we get, equation 4. Now let us see how we can solve this. Now from equation 1 and 2, you can get an expression for T1 and T2. So from equation 1, what is T1? T1 is 500 divided by V. And from equation 2, T2 is 750 divided by V. Now that means both these T1 and T2 can be replaced by V now. So they can be eliminated, and in the place of T1 and T2 you can put in terms of V. So substituting for T1 and T2 in equation 4. So T1 plus T2 is 500 by V plus 750 by V is equal to 250. Okay. So if you simplify this, 500 plus 750 is 1250. 1250 is equal to 250 times V by cross multiplication. So therefore V is equal to 5. I think you are going to get 5 meters per second. So this is one answer we got. So V is this value. That means the velocity, maximum velocity reached in the first phase, then it remains constant, then it reduces. So that means now we got this value of V. This value of V as 5 meters per second, and this also is 5 meters per second. Later on, it reduces to 0. So we got the value of V as 5 meters per second. Now what we can do here is, so what he has asked? Let us see. He has asked the value of A. A is the A1. A1 is the acceleration with which the train has started. So once we get the value of V as 5 meters per second, now we can easily find out the value of A by using that equation V is equal to U plus AT. So that is Very simple. So to use that equation, so now that means I have used the combination of graphical method and equation method. So for the first phase, now once again I will come back to first phase. Since it is the case of acceleration, the equation is v is equal to u plus at. Please note that for the first phase, u is 0, that is initial velocity is 0, acceleration is not known here, so that is a is not known here. Then t is nothing but t1. T1 is how much? T1 is 500 divided by v. So we got the value of v as 5. Therefore, this you will get this as 100 seconds. 100 seconds is the value of t. Now you know the value of u, you know the value of t, you know the value of v. You can find out a as the acceleration a is nothing but a1 for the first phase. A as v minus u divided by t. So from this equation, so v is 5 meters per second minus u is 0 divided by time is 100. Therefore, 5 divided by 100, 0.05 meter per second square. So this is the acceleration with which the train has started. So like this, you can find out any other unknown thing also by writing down the velocity time graph. So this is very important. So once you know how to write the velocity time graph, so what are all the data given, so you can just have those data and find out the area of velocity time graph. Area gives the displacement or the distance traveled. Using that concept, you can always find out the unknown thing. So here, of course, in this problem, time is given. In some of the problems, distance will be given. So total distance traveled will be given, or distance between 2 points will be given. That means S will be given. Once S is given, S1 plus S2 plus S3. That means if you add the areas of all these three, then you are going to get that total distance traveled between 2 points. Then later on time may be unknown, so you can find out the time. So like that, so one thing is this is the master graph. That means whenever a body is under motion, if it starts from rest, it reaches the maximum velocity up to certain time, covering certain distance. Then the velocity remains constant, so that the acceleration in that part will be 0 for certain time, and distance traveled will be S2, and then later on it takes some retardation, distance traveled is S3, time taken is T3. So either total time may be given or total distance may be given. So depending on that, so you have to analyze, you have to develop the equations first. Write down the equations for all the three phases, draw the diagram, find out the areas of the triangle, rectangle, write down the corresponding equations. Later on, whatever is known, those values you substitute, and then you will get the answer. Suppose in this problem, so let us see, in this problem, let us say that he has asked the retardation also. If he has asked the retardation also, I will tell you how to do the problem. So this note, if retardation is asked, so retardation means here I have taken that as A3. A3 is unknown. So for that, how to do? Once again, we know for the third phase, we have to write down the equations. So for the third phase, the equation is this: 25 into V is equal to S3. This is the equation. Since it is retardation, so we can use this equation: V is equal to U minus AD. This is the relation we got. This relation we can use to find out S3. I will come to that also. V is equal to U minus AD. In this, please note, when you take the third phase, this V becomes 5. Sorry, U becomes 5 meters per second, because this is the initial velocity. This is the final velocity. So final velocity becomes 0. So it should not confuse. So here he has asked this A. So what is the time? Time he has given. It is 50 seconds. For the third phase, time is 50 seconds. Now U is known, V is known, T is known. We can find out the retardation A3 as U minus v divided by t. So which is nothing but 5 minus 0 divided by 50, which comes out to be 0.1 meter per second square. This is retardation. Okay, I have used minus here. That is why it is retardation. If you use plus here, then you will get minus 0.1 meter per second square, which means the negative value, if it is acceleration is negative, it is retardation, it is understood. So this is how we have to do the problem. Suppose if we ask what is the total distance covered, what is the total distance covered by the train, then what we can do here is S3 you find out here. So S1 is given, so S1 is given as 250 meters, S2 is given as 750 meters, S3 is unknown. S3 can be obtained using this formula 25 into V. V is 5 meters per second. So 25 into 5, 125. 125 meters is the S3 distance. Now if you add all the three, you are going to get the value of total distance. That also will be asked. So under note I will write. So first one this, second one, if you ask total distance traveled, S is equal to S1 plus S2 plus S3. So then S1 you know it is given 250 meters, S2 is 750 meters, S3 you have to use from this equation 3. So this I am going to take directly equation 3. 25 into V is 5 meters per second, 125 meters. So therefore S is the sum of all these three, so 1125 meters. That is the total distance traveled by the train. So one the basic concept is that velocity time diagram whose area gives the distance traveled. So total area gives the total distance traveled. X-axis you have to show the time, y-axis you have to show the velocity, so that the slope of this velocity time graph and theta of this gives the acceleration. So please note that slope of Vt graph gives the acceleration. So that is the concept of velocity time graph.